In a very formal environment, the company might employ something known as object-oriented analysis and design, which describes a formal methodology to creating a formal design. Now, typically in object-oriented analysis and design, the business analysts and the software architects would spend a lot of time designing the software on paper. I use that term accommodatively. I'll explain in a moment. And that design might include some very specific things like the design of individual classes, the property names, the methods, even what values should be passed into a given method. And I'll describe how that's expressed in just a moment. And they may create designs that actually talk about the interactions between the various objects in the system. They might use a set of exercises like the ones that are laid out in this book. Since this is a little bit from that era, from the early 2000s, and those exercises can help uncover the design of the system. Where are the objects? What's a property and what's an object? And how do we know when it should interact? And what responsibility should we give it? Again, they do all this on paper, and I use that term on paper accommodatively. I mean it to say it's codified in some way, typically in a software tool that allows the analysts and the designers, the software architects, to collect and organize their analysis and their designs all in one collaborative space. Now, again, 2 decades ago, the analysis and design was expressed in something called UML, the Unified Modeling Language. And it was mostly a visual language of boxes and stick figures and lines and arrowheads. And they would use those in different combinations throughout a number of different documents that were output called artifacts. And those artifacts would present different facets of the design of the system. There were artifacts that were more verbose in nature as well, not just diagrams, but also written text. For example, there was a use case, and it outlined what's called a basic course of events, the typical steps that a user and the system would go through. The user would walk up to the terminal and push in their ATM code and hit enter, and the system would display this, and the user would do this, and the system would display this. It would also outline various edge cases, like what happens if the user enters the wrong code, what if the ATM doesn't have money in the machine anymore, and things of that nature. And so you had these artifacts, and some of the artifacts were more focused on analysis, speaking in very broad, generalized terms. Some were more focused on design, speaking in more system-specific or technology-specific terms. So it would actually take months and months, usually, to flesh out the entire system using this modeling language, documenting the requirements to this degree. Now, in some cases, after all of the design artifacts were created, the system, the software that you had would actually then use that design and spit out code for you. There were tools in Visual Studio, and they still exist, I think, in the enterprise version, that will do some of these sorts of things for you. If you have designed, method names with input parameters or properties, it'll go ahead and spit out and stub out all that code for you, and then you give it to the developers and they can go and tweak it. However, the level of detail that's required to document a system in that way to make it fully functional was beyond the capability of most tools. Otherwise, it probably wouldn't need any software developers today. We could just drag and drop our way to success, right? Now, the licenses for these tools were extremely expensive. There was one in particular I remember called Rational Rows, and that was all the rage back in the mid-1990s, and it cost thousands of dollars, and whoever was going to be, delegated the responsibility of doing the design, they would go to these very expensive training classes, and it was a much desired skill set at that time. Now, keep in mind, all of this activity around analysis and design would happen before the actual developers who would be building the software are even consulted. They may not even know they're on the project at this point, all right? So a lot of design work happens even before the developers are engaged. one of the first jobs that I actually worked at, there was this guy who architected this entire massive system using UML and the Rational Rose product, and I was fascinated with it at that point. I didn't know much about anything at that point. I was just learning everything. The thing that fascinated me the most, though, was that he wasn't a software developer. He came more from the business side of things, and what wound up happening was that the developers would take a look at the designs that this guy came up with, and they didn't know what to make of them. First of all, many of us didn't really even know much about object-oriented programming at that point, and we certainly couldn't make heads or tails in the philosophy behind some of the design decisions that he made. Furthermore, we were using Visual Basic 4.0, which at the time didn't fully implement all of the features of object-oriented programming, things that would have been necessary to have in order to fully implement his designs. And so we didn't really appreciate the design, and we tried to understand it. We tried to implement it to the best of our ability. But in retrospect, looking back at it, it was pretty over-engineered. It also, if my memory serves correctly, it in many cases violated some of the principles and the guidance that have since become standardized, I guess you could say, from a design perspective. So, for example, if I recall, the design heavily relied on inheritance. Inheritance was cool, right? And everybody wanted to use inheritance. Well, first of all, Visual Basic 4 didn't fully implement inheritance, again, if my memory serves correctly. And some inheritance is good, but too much is what's referred to as an anti-pattern, or rather, if you just want to use the term, it's a bad idea. That's acceptable as well. So you don't hear the term object-oriented analysis and design used as frequently anymore because it honestly didn't work very well. In fact, some of the early opponents to object-oriented analysis and design coined a phrase that I use in the title of this lesson called Big Upfront Design or Big Design Upfront. It's either BUDF or BDUF. I think BDUF is the correct acronym to describe this approach to the design of the system, where you do all of this design and analysis work up front, and then you toss it over the wall to the developers, and you walk away, and they go and implement it, and life is good. But there were a number of problems with this strategy, this BDUF strategy. First of all, it treated the development process and developers specifically as a commodity. Hey, all we need to do is just come up with this brilliant design, document it all, and then we'll throw it over, and the developers will know what to do. They'll go off and build it. It'll all be great. And that sounds good in theory, that you can just design something and then hire a bunch of inexpensive programmers to go off and build it. The problem with that is that the designs tended to only take into account what I would call the happy path. In other words, the most likely scenario, the most likely outcome. It didn't account for all of the edge cases. And so in many cases, the programmers were left thinking, okay, but what do I do in this situation? What do I do in that situation? A friend of mine was fond of saying that 80% of all code is there to address 20% of all problems or all of the edge cases. Now, in some cases, edge cases required a complete rethinking of the entire design. The edge case would reveal things about the system that weren't readily obvious as we got started. And often designers were thinking purely in business terms, but writing software requires a deep understanding of the technical constraints as well. For example, you can't just load the entire object graph from the database into memory and list out, everything in a grid, and then have users be able to just navigate their way through the grid. There was no accounting for the mechanism, the persistence mechanism of how you would do this in an effective manner from a memory perspective. How would you get this information, this data, from the server to the web browser or to the rich client, whatever the case might be. And so it was just trying to retrieve way too much information and throw it over the pipe. And I remember some of the very first builds of the software were extremely slow, and that caused management much consternation. But hey, we're just following the designs, right? This is what the dude told us to build. And so, yeah, from a business perspective, the guy knew what he was doing, but he wasn't technical. He didn't realize the constraints of a system, especially in that case in regards to persistence. The developers were often left to just go and figure it out on their own. And that kind of brings me to another one of these development as a commodity mindset problems, and that is the developers were completely abstracted away from the domain experts that were initially consulted during the design and analysis phase. So whenever a question about the design popped up, one of the developers not quite sure what they should do in this scenario, they may have to go through several layers of designers and analysts to get a simple question answered. And hopefully those people didn't move to another company or move to another department within or to another project inside of the existing company. And hopefully their memory was good enough that they could describe to you why they designed this particular component the way that they did. And so, like change, time also is one of the sworn enemies of the software developer, because software development is all about, especially in a team environment, it's all about collaboration and communication. And so when you stretch the time from the point where you design to the point where you implement, you stretch that way out, people's memories begin to get cloudy. They forget why they designed things or did things the way that they did, and they have trouble expressing that whenever they're questioned by the people actually doing the typing on the keyboard. And so the time lapse between design and development stretched the communication out and made it extremely difficult to collaborate on the design of the software. And that really brings us to the third issue with big design up front. It took forever to build an application this way. In fact, over the course of 3 or 6 months or even a year, the business needs would often change. So while the designer is designing the application, the business is going about business. Inevitably, there are tweaks and changes to the way that business is being done. By the time he finishes his design and he throws it over the wall to the software developers, the business could be changing out completely from under him. Now the developers have the design of the system in hand, printed out or on screen, and they're going through it and they're trying to make sense of it and they're trying to build software based on it. Meanwhile, the business is constantly ebbing and flowing and changing. And so by the time the developers were building the application, they were building on assumptions that were made months or maybe even in some cases a year ago, and it might not be true anymore. So when they actually go to demonstrate how the software works, the business analysts, the project sponsors, the stakeholders, they're looking at the demonstration and saying, this isn't what we need at all. Things have changed. Why didn't that get communicated? The developers were always left holding the bag because ultimately they're the ones doing the work. So this would often cause fundamental changes to the way that the software was built. The design documentation doesn't have any accounting for this new way, and now we're throwing out the documentation completely. And that gives us our reason number 4 why BDUF was a bad idea. When the design was no longer relevant because of its inherent flaws or because the business fundamentally changed and the given design didn't account for it, the codified versions of the design became obsolete and useless and pretty much a waste. You either had to work hard to keep the design documentation in line with the current state of the business and the current state of the software whenever it became obvious that the design was not implementable? I don't know. And so you had to commit to making sure that the design documentation stayed updated. And almost nobody did this because it was overwhelming. There was too much of it at that point. And so if you don't maintain something, it becomes useless over time. And that's what happened to much of the design documentation that came out of big design up front. The 5th problem with big design up front was during the course of the software development project, it was unclear exactly how far along the developers were in the software development project. Part of the strategy was that, hey, developers are just a bunch of code monkeys and they're interchangeable, and we can swap them out. We'll just give them enough work for a day or for a week or whatever the case might be. But the problem with that strategy was the developers didn't really understand then the breadth of the application scope. They only had what was immediately in front of them. They couldn't give you some idea on how long it would take to finish the application based on what they had available to them. And so often, and this would be number 6, they would work for weeks at a time on a given feature, but that might not include user interface, because after all, the user interface isn't all that important. The persistence layer isn't all that important. The only thing that really matters is this domain layer. All right, we get that right, everything else will take care of itself. And there's some truth to that. But the problem was they were creating the domain layer to the exclusion of everything else, meaning that they had no way to prove that the software was working, no way to demonstrate that the software was working or what it did. And so you typically would come in at the very end, build your user interface and your persistence layer, and then bam, it's all done at one time. And the very first time that the stakeholders sit down and look at it is the first time they've seen the application ever running. And now the criticisms come out. This isn't exactly what we wanted. I had something else in mind. This won't work for us because whatever. And now we have to go back to the drawing board. We have to throw out everything we've done and start over, or at least dramatically rework the code base. All right. And so once the feedback began to roll in, it was a little bit too late at that point to pivot. You had to pretty much rework the code base in dramatic ways, which introduced massive delays. And so I'm sure there were other problems too that just don't pop to mind right away, but I think you get the idea here that there are some inherent issues with big design up front. That's one of the reasons why in most companies it's not practiced as much anymore. You might find that in some companies that do all just complete outsourcing, the outsourcing company may request that everything is written down, and if it's not written down in extreme detail, then it won't get built. So that might be a case for some design up front if you're going to rely on some third parties, especially those that are overseas. But all of these issues came to a head at some point, and there were a group of developers that kind of led the revolt against big design up front. For too long, they had been blamed for the fact that the software was late and that it didn't do what the business needed, when in fact they were put in a position to fail. So this sparked a movement in software development circles around the late 1990s, early 2000s. We'll talk about that in the next video. See you there. Thanks.